Hello and welcome to another one of D's ADD videos. Today we're going to go over some basic solving trig equations. Always get into the form of trig function theta equals number by adding and subtracting any coefficients you might have front, and then take the arc whatever or sine whatever depending on what the trig function is to get rid of it on the left side. And then on the right side you're asking yourself what reference angle has a sine of 30 or cosine of 45, whatever you're looking for. Then figure out what quadrant you're in depending on the positive or negative sign of your what's after the equal sign on the other side of theta. And once you figure that out, if you're restricted between 0 and 2 pi, you're pretty much done. You just find your two angles. If not, then you got to add 2n pi or n pi depending on whether it's sine, cosine, cosecant, secant, or tangent, cotangent. So let's see that in action. That was really fast overview. If you need more detail, just go back and watch the concept video. What I recommend you do at the beginning of these things is you go off to the side and just write your chart. So you should be able to count to 4 by now, hopefully, and work your way back down. And this is going to be 0. And if we're doing radian measures, it starts with 6 and works your way down to 2. If we're doing degrees, this one's 30, 45, 60, and 90. Okay, and they're all divided by 2. And the first row is your sine, the second row is your cosine, and I will show you how it works here in a second. If you didn't watch the concept video, I recommend you do. The tangent's just the division of those two numbers, so 0 over root 4, which is 2, is going to be 2, 1 over root 3. The 2's will cancel when you're doing this. Again, watch the concept video if this doesn't make sense to you. So, with this memory dump already done, now our problems should go much faster. So let's look at this one. This one says we need a function that has a tangent of 1. We already see that there are no numerical coefficients in front of the tangent here. Nothing added, subtracted, so we can tan inverse both sides. So what this is going to do on the left side is cancel the tan. And on the right side, you got to ask yourself what angle, reference angle, has a tangent of 1. So if we come over here, we would see that we would be right here for reference angle of 1. So that would be pi over 4, 45 degrees. So in this case, we would ask ourselves, where is tangent positive? Because of the positive 1 here. And it's positive in the first quadrant and in the third quadrant. And if you're just doing degrees, 45 degrees in the first quadrant would be 45, and in the third quadrant would be 180 plus 45, which is 225. Usually you're asked for radian measure answers, so I'm going to do that as well. And in the first quadrant, it's always pi numerator, and if the reference angle is 45, you get a 4 denominator. Always. So I can go ahead and write my denominator of 4 here for radian degrees. And then this is the third quadrant. If you remember the relationship between top and bottom, the third quadrant is going to be 1 more. Okay. So if we were restricted, all these problems, I'm sorry, are restricted 0 to 2 pi. I'll redo these problems without the restrictions, but for now we're going to do them with restrictions. So you're done, and you move on to the next problem. So in this case, we have cosecant equals negative 2 root 3 over 3. Let's deal with sines and cosines since that's what we're used to. So what we would do is we would flip both sides, and we would have sine theta equals negative 3 over 2 root 3. And if you rationalize, you get a 3 multiplied on top and bottom, and you're going to get negative 3 root 3 over 2 times 3, and you should see the 3's cancel. So you have sine theta equals negative root 3 over 2. now you inverse sine both sides, and you're basically going to be asking yourself what theta values have a sine of root 3 over 2. You don't necessarily need to write the sine inverse. You can if you want to, or arc sine. So where is sine equal to root 3 over 2? Go to your handy table. So where is sine of theta equal to root 3 over 2? What reference angle? That would be 60 degrees with a 3 denominator. Depending on what quadrant we have, the numerator will change because it's root 3 over 2, and sine is what we're looking for, root 3 over 2. Okay, so if we're doing that, what happens is we need to figure out what quadrant sine is negative in, and that's in the third and the fourth quadrant. If you did the acronym, all students take calculus. If you don't know what that means, watch a concept video. And in the third quadrant, it's 1 more than the denominator. Oops, sorry, it was a 3 denominator, right? For a 60-degree reference angle, and that would be 4 pi over 3. And then twice the denominator minus 1 for the fourth quadrant. Okay. All right, next problem. So this problem here, we got some numerical coefficients and stuff added, subtracted. So get it to where it's just a trig function on one side, and you get negative 4 cosine theta equals negative 8. Cosine theta equals 2 if you divide both sides by 4, negative 4. So because cosine and sine oscillate between 1 and negative 1, they will never reach any values outside of that. So if you ever see a value that's outside 1 and negative 1, then you write no solution, or the symbol for no solution as I just did. Okay? Let's look at this one here, another one in which we have a problem that's not explicitly solved for the trig function, so you got to do that. And you got to divide both sides by the negative 3, and you'll get tan squared equals 1 over 3. And you square root both sides, and in doing so you're going to get tan theta equals plus or minus 1 over 3, which is plus or minus 1 over root 3, because the square root of 1 is 1. So now we in essence have two problems. We have one that says tan theta equals 1 over root 3, and the other one is tan theta equals negative 1 over root 3. So in this case, we're going to have to determine what reference angle has a tangent of 1 over 3, root 3, and if we come over here, that would be this one underlined here, which is 30 degrees or a 6th denominator. So the reference angle of 30 degrees always has a 6th denominator no matter what quadrant we are. And when we take the arctan of both sides, we get rid of the tangent on the left side, and we ask ourselves which one of the angles on the right have a tangent of 1 over root 3 that's positive. And positive is in quadrants 1 and 3, and 2 and 4 would be the negative quadrants. So we have in the first quadrant, pi is the numerator. In the third quadrant, it's 1 more than the denominator and then the pi. Oops, we're not quite done, are we? Getting a little ahead of myself. And then on this one, we have theta would be equal to the other two quadrants, so that'd be the second quadrant, which is 1 less than the denominator. And then the fourth quadrant, where tangent's also negative, would be twice the denominator minus 1. And that would be your final answer there. So it's basically looking for 30 degrees in every quadrant. Last problem, we got a little bit more interesting problem here. as usual, just solve for the trig function. So if I subtract 3 pi from both sides, I get minus pi sine 3x equals pi. Divide both sides by negative pi, I get sine 3x equals negative 1. So what this is asking me is, where does sine equal negative 1? But you have to take in the fact that there's a coefficient of 3. So either you can use your sum to product identities, or in my idea, it's just easier to do this. What this question is asking you for is, where does sine equal 1? Negative 1, actually, sorry. So if you remember, 1 and negative 1 occurs only on the 0, pi over 2, pi, and 3 pi over 2 angles. So if you wrote the point 1 comma 0 went out 1, or 0 comma 1, negative 1 comma 0, 0 comma negative 1. So the first one is cosine and the second one is sine, and we see that sine is negative 1 right here at the angle of 3 pi over 2. Okay? Now, the problem with that, when you do sine inverse and sine inverse, both sides, you're going to be left with 3x equals the 3 pi over 2. And we got to go 3 times around the unit circle because of this 3 coefficient right here. Whatever this number is, that's how many times you go around the unit circle, and you add those answers right here. So to get the next one, what I do is I go off to the side and I add 2 pi, because the only place that sine equals a negative 1 is on this angle here. But if we keep going around the unit circle, every time we hit that, it'll equal negative 1. If you remember, again, sine oscillates back and forth, so there'll be multiple times that we'll hit this negative 1 value. So again, 3 pi over 2 plus 2 pi with a common denominator of 2 would be, oops, that's a plus sign, not a common sign, would be a 7 pi over 2. And then 11 pi over 2. So this was the first revolution. Here's the second revolution, and then the third revolution. So we're done there. And then divide both sides by 3. And there's your answer there, okay? So make sure you check out the same problems that are solved without restriction. All these problems, again, are solved with restriction from 0 to 2 pi. The rest of them, when I redo these, will be solved without any restrictions. All right? So I hope I've clarified any confusion that you might have. Practice, practice, practice is the key. Thank you, and have a nice day.